Good morning, 8th grade. Let's go ahead and continue our conversation about prisms. Today, specifically, we're going to talk about the surface area of prisms. So this is the worksheet from your paper packet. So we're going to review those as examples. And then you have a short assignment in OneNote that is due by Friday. Starting off, we're going to talk about rectangular prisms. So what you are doing when you find the surface area of a rectangular prism is you're basically doing this. There are 3 pairs of sides on a rectangular prism for a total of 6 sides. You've got this side, let's call that the front, and then you're going to have an identical rectangle on the back. Then we've got this guy up here on the top, and then of course you're going to have an identical rectangle excuse me, on the bottom. And then finally you've got this side here on the right, and of course you're going to have an identical side to that on the left. Now we know how to find the area of a rectangle. So all we need to do is to find the area of each of the 3 rectangles we can see and multiply by 2. In other words, we find the area of this right-hand face and then multiply our result by 2 because there's also a left-hand face. How big is this face on the side? Well, across the top here, it's 1.1. And then the top to bottom here is 1.7. So plug that into your calculator, 1.1 times 1.7, and you get 1.87. But remember, that's only the area of this right-hand rectangle. There's also a left-hand rectangle, a left-hand face, that is identical. So we got to multiply by 2 to include the left-hand face. 1.87 multiplied by 2 is 3.74. So that takes care of our right and left. Let's switch back to the top. Up top here, we've got this top rectangle, this top face, and there's an identical rectangle or face on the bottom. So let's figure out how big this top rectangle is. Well, this dimension here is 1.1, and then this dimension this way is 3. Multiply those together, you're going to get 3.3. But that's how big this top face, this top rectangle is. But remember, there's an identical one on the bottom. So we got to multiply by 2 to include the bottom, which gives us 6.6. All right. Finally, we have the front and the back. So here's our front right here. Let me yoink. Oh, erase the whole thing. Here's our front right here. And there's going to be an identical rectangle on the back. How big is this rectangle? Well, it's 3 across. And then this dimension is 1.7. What is 3 multiplied by 1.7? According to my calculator, that would be 5.1. But wait, that's only the area of this front face. We also have to include the back, which is identical, so we're going to multiply by 2. 5.1 times 2 is going to be 10.2. Once we've done that, we've accounted for all 6 sides, we add up our results. So 3.74 plus 6.6 plus 10.2. That's going to give us a total surface area of 20.54. And since these are all in centimeters, we put centimeters. And anything with the word area is going to be squared. Volume is to the 3rd power. Surface area is always squared. Now there is a shorter version, or not a shorter version, there is a way that we can break this down into a simpler formula. If you notice, what we've done here is we've taken every possible combination of the 3 measurements we know. We did 1.1 times 1.7, we did 1.1 times 3, and we did 3 times 1.7. Every single possible combination of the 3 measurements we know, we multiplied together. And then we just multiplied everything by 2. So if you remember that, if you take each possible pair of the 3 measurements, your front to back multiplied by your up and down, your front to back multiplied by your left and your left and right multiplied by your up and down, and then take those results and just multiply everything by 2, you should get the same result. That's the formula version of this process. And usually you're going to see it written as 2 length times width plus 2 length times height plus 2 width times height. But if that formula doesn't quite stick in your brain, just break this down into the rectangles you know, and then multiply your results by 2. Let's do another example over here with this tall boy. I'm going to use the same colors. And then we'll move on to the triangles, because I know those are the ones that have been confusing the most people, and that's fair because they can be confusing. All right, so what is our front and back? We have our front face here in red, and that is 10 across by 40 tall, so that's 400. And then dark green for our sides. Here's our right-hand side. That's a terrible drawing. There we go. And our right-hand side is 12 by 40. 12 times 40 is going to be 480. And then in blue, we've got our top, which is going to match up with our bottom, of course. Our top is going to be 10 across and 12 front to back. That would be 120. Okay? So I just found the area of each individual rectangle. 40 by 10 gives us 400. 40 by 12 gives us 480. And then 10 by 12 gives us 120. But then we have to multiply all of those by 2, because we have this top that's 120. We're going to have an identical bottom. So that's going to be 120 times 2 is 240. And then we're going to have this 480 on the right, but you're going to have an identical rectangle on the left. 480 by 2 is 960. And finally, we've got this 400 on the front, but we're going to have an identical one on the back. 400 times 2 is 800. So let's add all those together. 240 plus 960 plus 800. According to my calculator, that comes out as exactly 2 1,000. Okay. We have millimeters. Surface area is always raised to the second power, millimeters squared. All right, so that should be a good start on how to do rectangular prisms. Let's talk about triangles. Specifically, I want to start with this one, number 4. Let me do something real quick. Actually, let's jump down to number 6, and I have my reasons for this. So we can think about this the same way that we did these guys up here, right? We have a top and a bottom, a front and a back, a left and a right, so on. Let's look at this guy. So the front of this prism is this right triangle. And there's an identical right triangle at the back of the prism. So if we want to find the surface area, we need to find the area of these triangles. And then whatever that result is, well, we can find the area of this front triangle, and then because there's an identical one on the back, we can multiply by 2. So let's think back. What is the formula to find the area of a triangle? Well, we need to go how wide it is left to right, multiplied by how tall it is bottom to top. Width times height. So we have those two measurements. We have 25 for our left to right width, and we have 15 for our bottom to top height. What does that give us? 25 times 15 is 375. But wait, this is a triangle. Triangles have to include an extra step, which is to divide by 2. So what is 375 divided by 2? You're going to get 187.5. So the area of this triangle in the front is 187.5. But remember, there's a second triangle back here that's identical. So just like we did up here with the front and the back and so on, we have to multiply this by 2 to take into account that there's 2 of them. 187.5 divided by 2 is 375. All right, that's a start. But we're not done yet because there are all these, the center section that connects these two triangles has a series of rectangles. So for example, there's this rectangle, this kind of slanted side. Yeah? So we can find the area of a rectangle. That's no problem. We know that this dimension of the rectangle is 40. It's 40 yards wide. But then we need to know the other dimension of the rectangle, which is this. We don't have that number. It's not written on the sheet. So we have to use the Pythagorean theorem. A squared plus b squared equals c squared. We know a and b, and we need to find c. How do we do that? We're going to do a squared, so 15 squared, plus b squared, that's going to be 25 squared, equals c squared. So grab your calculator. 15 to the second power plus 25 to the second power gives us 850. Well, we're not done yet though, because this is c squared. If I want to find c, I have to get rid of the squared part. So I need to find the square root of 850. We're going to round this off to 29. It's actually like 29 and a little more, but we're just going to call this 29. So now we know both dimensions of this rectangle. We know this is 29 and this is 40. What is 40 multiplied by 29? 40 times 29 is 1,160. All right, not done yet. Got plenty of colors to use here. What about this rectangle? Let me erase that real quick. Oh no, the whole thing went away. Oh, okay. I hope you guys remember how that worked out. And actually, removing some of the drawings will help us with these coming drawings, because everything kind of overlaps each other. So let's jump. Now we're going to worry about this rectangle, the bottom. This by this by this. It's hard drawing with a mouse. This guy down here. You see him. Yeah. Okay. Well, how do we find the area of that rectangle? Well, we know this dimension, front to back, is 40. And we know this dimension across is 25. 40 times 25 is 1,000. We got one more triangle to deal with. We'll make this one purple, and that's this guy back here. This side wall, right? Yeah? Okay, well, what's the dimensions of this rectangle? Well, it's 15 from bottom to top, and it's 40 from front to back. 15 times 40 is 600. Now we have accounted for the front triangle and the back triangle. That's here in red. We accounted for this slanted top part by doing the Pythagorean theorem. That's in blue. We accounted for the floor in green. That's 1,000. And we accounted for the wall in purple. That's 600. Now we got to add all those together. 375 plus 1160 plus 1,000 plus 600 equals the total surface area of this triangular prism is 3,135 yards squared. It's a long process. It takes a number of steps to get this done. A couple of shortcuts. One, if you figure out the front triangle, multiply by 2 and you've got the back triangle. You don't have to figure them out separately. 2, I want to point this out. Notice that for all 3 of the rectangles that we did, the floor, the wall, and the slant, all 3 of them included our front to back measurement, 40. We multiplied our front to back measurement, 40, by each side of the front triangle. We did 40 by 25 to get the floor. We did 40 by 15 to get the wall. And we did 40 by 29 to get the slant. So there is a shortcut here. You can just multiply your front to back measurement by each side of your triangular face. Then add those together, add in the front and back triangles, you've got your answer. This video is getting quite long, and I know you guys have plenty of work to do. So I want to go through this guy real quick, and then we'll be done for this lesson. Okay, so first off, we need to figure out the area of this front triangle, which is going to be the same as this back triangle. Well, that's easy. It's 21 from left to right multiplied by 18 from bottom to top, and then because it's a triangle, you divide by 2. 21 times 18 divided by 2 gives us 189. But wait a minute, there's a front and there's a back. There's two of them. So we're going to multiply this by 2, which gives us 378. Now, let's talk about the rectangles that connect. So we have this rectangle on the right-hand side facing us, this guy here. Right? If I color that in, it looks like a wall. Yeah? Well, what are the dimensions of that rectangle going to be? Go down to our shortcut down here. Remember we multiplied our front to back measurement by each side of the triangle. Well, what are the sides of this triangle on the front? From across the bottom, it's 21. And we see these little notches on each side. This is an equilateral triangle. So this side's also going to be 21. And this side's also going to be 21. So if we do our shortcut of multiplying the front to back measurement by each side of the triangle, in this case, every single time we're going to multiply by the same number. We're going to multiply 35, our front to back number, by 21, and that'll give us this colored in right-hand face, because it's 35 times this guy, this side. Then we're also going to do 35 times 21 across the bottom. That's going to help us find the floor. Oops, didn't mean to do that. The floor, the part that's on the bottom, that's going to be another 35 times 21. And then this side, the left-hand wall that we can kind of not see, this is 21, and the front to back is still 35. So we multiply the front to back by each side of the triangle, which is going to be the same as 35 times 21 times 3. That's 2205. And then we add that to the 378 from the triangles. We get a total surface area of 2,583 millimeters squared. All right, let's talk about the Pythagorean theorem on this guy, and then I will let you go to your own homework. So we know A, and we know B, and we need to find C. So A is 5 squared. B is 4.5, so add 4.5 squared. So we get 5 squared, remember this is the Pythagorean theorem, plus 4.5 squared. And that's going to give us a total of 45.25. So that's our C squared. So to find C, we find the square root of 45.25, and we get C equals 6.7. So this guy becomes 6.7. Okay, so how do we find the surface area of this? Well, we have our front triangle, which is going to be identical to the back triangle. We know our left to right measurement and our straight up and down measurement, so we can do 4.5 times 5 divided by 2. 4.5 times 5 divided by 2 is 11.25. But then there's a back as well that's identical. Multiply it by 2. That's going to be 22.5. Okay, and then this is the trick I want you to remember for triangular prisms. Multiply your front and back distance, which in this case is going to be 8. Multiply it by each measurement of the front triangle. So you need to do 8 multiplied by 4.5. And then you do 8 multiplied by 5. And then you do 8 multiplied by 6.7. So you multiplied it by the left to right, you multiplied it by the top to bottom, and then you multiply it by the connecting slant. Multiply your front to back measurement by each side of the front triangle, then add everything together. All right. There's a very similar assignment for you to do. Try to have it done by the end of the day today. It is truly due on Friday, as is everything in this week of work. Stay safe, wash your hands. I hope to see you soon. Bye.